Welcome to Study Loop.
This is the answer to Chapter 22, problem number 18 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a stepwise mechanism for this Fischer esterification, and it's an intramolecular Fischer esterification. So the alcohol and the carboxylic acid are part of the same molecule, and we end up with a cyclic ester or a lactone, as they are also known. And so the thing to remember about this mechanism, and indeed about all the mechanisms from this chapter, is that the nucleophile is going to attack the electrophilic carbon of the carbonyl. A tetrahedral intermediate will form. One of the oxygens will then close back down, and the best leaving group will be kicked out. And that's essentially the mechanism for every single one of the reactions at least the key reactions that we're looking at in this chapter. And so, as I always like to do, I've drawn lone pairs of electrons, charges, and movement of electrons in blue, and everything else in black. And so the first step of this reaction is going to be protonation of the carbonyl oxygen by the sulfuric acid. And so, of course, we draw that as a lone pair on the oxygen, attacking the hydrogen of the sulfuric acid, the HO bond breaking, and those electrons reverting to the oxygen. So we now have a charged protonated carbonyl oxygen. This is going to, of course, make the carbonyl carbon even more electrophilic and susceptible to nucleophilic attack, which is indeed what happens. The attack is by this pendant alcohol. Pendant means attached to the same molecule. So this alcohol, part of the same molecule as the carboxylic acid, but far enough away that it has good freedom of movement. And so it can swing under and attack. And once it does that, as it's doing that, one of the two double bonds is going to break, and those electrons are going to revert to the carbonyl oxygen. And so at that point, we have the famed tetrahedral intermediate. So this carbon, which was the carbonyl carbon, now has four distinct bonds. The charges on this oxygen, which was the alcohol oxygen. And so we have this sulfate ion floating about in solution. It will pluck this proton from that oxygen. The electrons of that bond will revert to the oxygen. This relieves the positive charge on this oxygen. And so here we have a neutral tetrahedral species with the acetal. And so one of these two alcohol oxygens will do another attack on the hydrogen of another molecule of sulfuric acid. So again, this will then get protonated. So once it's protonated, it's a good leaving group. So then it can leave while simultaneously one of the lone pairs on this other oxygen reattacks what was the carbonyl carbon to reform the carbonyl, the CO double bond there. And so that's happened here in this final intermediate. And then again, another sulfate is going to come and pluck this hydrogen to relieve this positive charge on the oxygen. And then just for sake of clarity, I suppose I should... Oops, why is it that color? I should put the lone pairs here. But yeah, that's it. That's the stepwise mechanism for this problem. And again, for any problem dealing with a carboxylic acid derivative, you're probably going to see the same or very similar steps where the carbonyl oxygen is protonated. This allows nucleophilic attack. A tetrahedral intermediate forms. And then the tetrahedral intermediate will close down, and the weakest leaving group, or pardon me, the best leaving group will be kicked out, and then the newly formed carbonyl oxygen will be deprotonated to reform your carbonyl. And that's how most of these carboxylic acid derivative reactions work. And that's certainly the way that this one works. And that's the answer to chapter 22, problem number 18.